Hello friends, this is the ninth video of data science playlist and today we'll discuss about regression modeling in data science. Regression modeling in data science refers to the process of predicting a continuous target variable based on one or more input features. It is a supervised learning technique where a goal is modeled the relationship between dependent variable target and independent variable feature. Types of regression. Linear regression, the simplest form of regression where the relationship between the target variable and the input variable is assumed to be linear. Simple linear regression predicts the target variable using a single feature. Multiple linear regression extend to multiple features predictors. Second is polynomial regression, a type of regression where the relationship between the target and the predictor is modeled nth degree polynomial. This allows for non-linear relationship but still uses a linear equation and transport features. Third is ridge regression, means L2 regularization, a variation of linear regression that adds penalty term to the cost function and prevent overfitting by shrinking the coefficient. Fourth is lasso regression, L1 regularization, another regularization technique that adds penalty to the absolute value of coefficient which can lead to sparsity. Fifth is elastic net regression. Elastic net regression means a combination of both lasso and ridge regression useful when there are multiple correlated features. Sixth is logistic regression. Though the name regression logistic regression is used for binary classification tasks, it estimates the probability of an event occurring using a logistic function. Key components of regression are dependent variable, the variable we are trying to predict, houses, price, etc. Independent variable, the variable used for prediction like rooms, number of rooms, square footage, etc. Coefficient, parameters that define the influence of each feature on the target. So now we'll move to the next slide, which is introduction to linear regression. Linear regression explores the linear relationship between the dependent variable and one more independent variable. It aims to find the best fitting line that represents this relationship and allows us to predict the value of dependent variable based on the independent variable. First is relationship analysis. Determines the strength and direction of relationship between the variables. Second is predictive modeling. It means develop a model to predict value of a dependent variable based on the independent variable. Next is simple linear regression in R and Python. Simple linear regression involves one independent variable and one dependent variable. We'll use R and Python perform this analysis, estimate the model coefficients, value its performance. In R, IM function used for model creation, summary function used for model summary, predict function used for predictions. In Python, stats models.formula.api.ols for model creation, model.summary for model summary, model.predict for predictions. Next is multiple linear regression in R and Python. Multiple linear regression extend the simple linear regression to conclude multiple independent variables. This technique helps us to understand the combined effect of multiple factors dependent on the variable. First is model creation. I am in R and stats model.formula.api.ols in Python. Second is model summary. Summary in R, model.summary in Python. Third is model evaluation. Multiple metrics include R square, adjust R square, p values, and confidence intervals. Next is assessing model fit and diagnostics. After fitting a regression model, it is crucial to assess its fit and diagnose any potential problem. This helps to ensure model is reliable, provides accurate predictions. R square measures the proportion of variation in independent variable explained by the independent variables. Adjust R square penalize the model for including unnecessary independent variables. F static test the overall significance of the model, indicating whether there is a relationship between dependent and independent variable. P values assess the statistic significance of independent individual values. Next is stepwise regression techniques. Stepwise regression technique is method used to select the optimal set of independent variables for a regression model. It involves iteratively adding or removing variables on their statistic significance, aiming to achieve the best model fit with fewest variables. First is forward selection. Starts with an empty model and iteratively adds the most significant variable at each step. Starts with a full model, iteratively removes the least significant variable at each step. Step 5 regression. Combine both forward and backward step, adding, removing variable based on their significance. Next is implementing stepwise regression in R and Python. First is R and Python offers function for implementing stepwise regression. These functions automate the process of adding or removing the variable based on predefined criteria. In R, we use step function for stepwise regression, direct equal to forward for forward selection, direct equal to backward for backward elimination. In Python, we use states.model.formula.api.ols for model creation, model.fit for model fitting, model.summary for model summary. Next, we read interpreting stepwise regression results. The result of stepwise regression provide an information about the selected variables and their significance. By analyzing the coefficient p values, r values, we can interpret the relationship between the selected variables. Coefficient indicate the strength and direction of relation between each independent variable and dependent variable. P values assess the statistical significance of each independent variable, and R squared measures the proportion variable in the dependent variable explained by the selected independent variable. Next is evaluating final regression model. After performing stepwise regression, we need to evaluate final model performance. This involves model fit, making prediction and interpreting results, as you can see in the PPT. So the last topic is applying a regression case study. As you can see in the PPT, there's a table about data exploration and model building. Data exploration means understanding data is essential before building a model, and model building is utilizing a chosen regression technique to build a model. So this was all for today's lecture. If you like the video, make sure to hit the like button, share the video, subscribe the channel. Thanks for watching.